A block of mass m moves on a horizontal circle against the wall of a cylindrical room of radius r. The floor of the room on which the block moves is smooth, but the friction coefficient between the wall and the block is mu. The block is given an initial speed v0. As a function of the speed v, write the normal force by the wall on the block, the frictional force by the wall, the tangential acceleration of the block, and the last part integrate the tangential acceleration to obtain the speed of the block after one revolution. So if we consider this kind of a system where a block is kept in a cylindrical room and it is rotating, so I can draw it in this way, that we are considering cylindrical room like this, which is of radius r. So I'm drawing a central line. So the radius of this cylindrical room is r. The floor is perfectly smooth, but the friction coefficient is offered by the wall, and the friction coefficient is equal to mu. So we are fixing a block over here in contact with the wall, and it is given an initial speed of v0. So the initial speed is equal to v0. So the first thing which we can say is, due to the speed, the force mv square by r is going to act on the wall, and the force which is equal to mv square by r will be balanced by the normal reaction force exerted by the wall. So for the first part, the value of normal reaction force by the wall on the block is going to be mv square by r. So now I can say that the value of the friction is equal to mu n, and if it is equal to mu n, so we can write the value of frictional force as equal to mu mv square upon r. The next thing that is asked is the tangential acceleration of the block. Now due to the frictional force, the block which was initially started with a initial velocity v0 will undergo retardation, and we can say that the value of friction is going to produce a retardation of mu mv square by r can be equated with mass into acceleration, and it will be with a negative sign. So we can say that the value of acceleration, which is actually retardation, the cause of retardation, will be equal to mu v square upon r with a negative sign. So this is the value of tangential acceleration of the block. Now in the next part, it is asking us to integrate the tangential acceleration to obtain the speed of the block after one revolution. So if we start solving for this part, so we can consider it in this way, that dv by dt, which was the tangential acceleration, so we can write it as v dv by ds, and this is equal to, we have already obtained it as mu v square upon r. So from here we can write this equation as ds is equal to minus r by mu dv by v. So the question is asking us after one revolution. So after one revolution we can easily put the value and integrate this particular equation. So now at the initial position the value is v0, and maybe after one revolution the value of velocity will become v. So we are asked to calculate the speed of the block after one revolution. So we can say that the speed after one revolution is equal to v, and for the value of displacement we are saying initially it was 0 and finally it will be s. So I can write it as s is equal to minus r by mu ln of v by v0. So this is what we obtain from here. Now over here I can put that the displacement, the s is equal to 2 pi r, because this is the distance which the block actually covered, and the value of frictional force was acting throughout this path. So we cannot write it as displacement, we have to write it in terms of the distance traveled, because the frictional force is non-conservative in nature. So we can say that the value is equal to 2 pi r, which is equal to minus r by mu ln of v by v naught, and from here we obtain the expression for v as v naught e to the power minus 2 pi v. So this is the final expression for velocity that we obtain, that v is equal to v naught e to the power minus 2 pi v.